Alright, nature of the roots of a quadratic equation. Now a quadratic equation is a parabola, right?
Yes.
So in general, the way that you are tested in an exam, this is it, most of the time. So we're going to get a bit technical, and we're going to get a little bit more higher level of type of sums that can be asked, but it's very seldomly asked, but I have to do it with you. In general, if we look at a parabola, and I want to ask you the nature of the roots, we've done this now before, what would you say for the nature of these roots? Usually we write three things, right?
Yes, ma'am.
Whether it's real or non-real, first of all. Then whether it's rational or irrational, unequal or equal. What does that mean?
Two solutions.
Two solutions or just
One.
Right. So in this case, we have real roots. We have
Quadratic, rational,
irrational. Because if one of them is irrational, then the nature of the roots are irrational.
Oh.
And equal or unequal? Unequal. And that's just, unfortunately, we cannot say there are two of them, you've got to say unequal, because that's the way that you are asked. Real irrational, and make sure I can see that little thing there. If you don't remember the sign, you write irrational. For this one, the roots are real, first of all. Rational, because it's not a root.
And then equal.
And then equal. Excellent. Why?
Because of one
There's
solution.
only one x-intercept. Please remember that roots are x-intercepts.
Oh.
That's what roots are. So if I ask you the roots, don't go get me some roots from the tree. Roots are x-intercepts. Alright. And also we talk about, that's a root value. Actually, that's why it's better to talk about surds. Alright. So, for the last one, nature of the roots. Non-real. What is the nature of the x-intercept? There's no x-intercept, so it doesn't exist. So it's non-real. Are you with me?
Yes.
Generally, that's enough. Generally. Except if it's a higher order sum. Now, in a higher order sum, we're going to find that the nature of roots is determined by the quadratic formula, and I'm teaching you that now. That if you go to the quadratic formula, focus, then the determiner, whether it's going to be rational or irrational, is going to be all about that little value sitting right there in your formula for your quadratic formula. That will determine whether the sum can come out of the root or not. And that will make it either rational or irrational. The moment that there's a root answer, it's irrational. If there's no root answer, it's rational. So if I go full in my ABC here, and there is something inside there that can't come out of there, it'll be irrational. If it can come out there, now what does it have to look like to can come out there? Something like, for example, 6? No, can't come out. 9? Why 9? Because it's a perfect square and can come out of the square root. 11? No, it's going to be irrational. So we're just getting onto the irrational stuff there. So if this thing is a perfect square, it can come out. So I'm going to jump around here and say, for rational, that discriminant, I'm calling it the discriminant because it's a discriminator between rational or irrational, equal or unequal. It separates, it discriminates, well, what's another word I can use for it? It discerns between two things. So the discriminant, that's the word I'm looking for, which nobody's going to ask you, but they'll talk about it maybe, and you've got to know, is called, and this is delta. Maybe you've heard about it in physics. This is delta, but delta now is called the discriminant, and that's only the little piecey there inside of the root. That discriminates whether you're going to have real, non-real, equal, unequal, rational, or irrational. It must make sense to you once you've got it. So first of all, real roots will be there are answers. So when will there be answers? If this thing,
It's a perfect square.
no, not a perfect square. If there is something that's not non-real, when will it be non-real? If this thing inside is a negative, how am I going to say it's negative? The discriminant is negative. Do you hear my English? The discriminant is negative. Make sense?
Yes.
So when will it be real? If the discriminant
Is a
is,
positive.
but can it be 0? Because now I don't have 0 anywhere. If that was 0, you still have an answer. Yeah? But you're going to have one answer, not 2. So if it's equal to 0, that's fine. You're still going to have real roots. Let's go for equal roots. Equal roots I've just touched on now. When will there just be one answer? If it's not plus something and minus something. So if this plus minus is 0. If that discriminant is precisely equal to 0, then this falls away. So there's no plus and minus sum, is one sum. So one sum means one answer means equal roots. So for unequal roots, I didn't write it here. For unequal roots, it would mean that the discriminant is not equal, just bigger. So it has to be real, but it's not bigger. It's not negative, and it's not equal to 0, which makes it equal roots. Rational roots. So now tell me where I started off. So when will this come out of the root? If it's a
Perfect square.
and if it's irrational,
Then it's not.
it's not a perfect
Square.
square. So in essence, that's your whole little summary for nature of the roots.